Welcome to video 10.7b, opposite angles of an inscribed polygon. Alright, so we got one theorem and a couple examples. Let's get right to it. So theorem, if a quadrilateral is inscribed inside of a circle, then the opposite angles of that quadrilateral are supplementary. Let's investigate that right here. Alright, so we've got a quadrilateral inscribed inside of a circle. Notice that the measure of angle A would be 1/2 of arc DCB. It's an inscribed angle. Notice that angle C would be 1/2 of arc DB. Oh, notice that those two arcs in question sum 360. So if A is half of this and C is half of this and those two halves are 360, I can just say half of 360 is 180. So half of 360 equals 180 degrees, and that's where that theorem is derived from. All right, so just concretely here, to use the theorem, I would know angle A plus angle C equals 180 degrees, or I could say angle B plus angle D equals 180 degrees. Now let's use that theorem into examples. All right, example 1. Find the measure of major arc QUA. So 3 letters, that means we're going to be going more than 180 degrees. So first let's identify what we're looking for. We're looking for that arc right there. All right, there's a couple ways of doing it, but let me do it the way that uses the new theorem. Oh, I've got an inscribed quadrilateral, so if this angle is 50, this angle must be the supplement of 50, which would be 130 degrees. Oh, this angle 130 intercepts this arc that I'm trying to find. So I know an inscribed angle is half of the intercepted arc. So I'll just write an equation. 130 degrees equals 1/2 of QUA. So to solve for QUA, I would just simply double it. So QUA equals 2 times 130 equals 260 degrees. Okay, that wasn't too bad. Example 2. Find the measure of minor arc BC. So, looking for this one right there. Okay, so the problem gave angle C as 160 degrees, so you can write that in. Again, we've got an inscribed quadrilateral. Let's just go right to it. If you're 160, you're the supplement, you would be 20 degrees. Oh, that's also an inscribed angle. So an inscribed angle is half the intercepted arc. So in this case, the intercepted arc is that whole arc. So just say angle A equals 1/2 of arc BD. So arc BD, just double that, would be 2 times 20 equals 40 degrees. Well, we were also given these two chords were congruent. So if these two chords are congruent, then of course these two arcs are congruent. So I've got two congruent arcs that sum 40. So arc BC must be half of that. So BC equals 1/2 of 40 equals 20 degrees. So there you have it. A theorem on a quadrilateral inscribed in a circle and 2 basic examples applying it.